Nanotechnology Chapter 8.3 Properties of Nanoshell Particles, reported to you by Ian Paul T. Salya, TUP Visayas. Nanoshell particles. The surface modification of colloidal particles through the coating of the shell offers a flexible way to modify their surface properties, including their chemical, reactive, optical, magnetic, and catalytic properties. This report will discuss the enhancement of luminescent properties of colloidal particles, including CDSE nanoparticles coated with CDS or ZNTE, and CDTE nanoparticles coated with CDS, as well as the use of doped semiconductor nanoparticles embedded inside a single silica particle. CDSE nanoparticles coated with CDS or ZNTE have been studied for their luminescent properties. The coating of CDSE nanoparticles with CDS and ZNTE shell results in a type 2 core shell heterostructure, which enhances their luminescent properties. The luminescence of CDSE-CDS or CDSE-ZNTE core shell nanoparticles can be tuned by adjusting the shell thickness. CDTE nanoparticles coated with CDSE have been studied for their luminescent properties. The CDSE core shell nano exhibit the luminescent compared to the bare CDTE nanoparticles. The luminescent enhancement is attributed to the type 1 band alignment between the CDTE core and CDS shell. Doped semiconductor particles such as ZNS, doped with Mn, can be embedded inside a single silica particle. These doped semiconductor nanoparticles are highly efficient fluorescent materials, and the coating of dielectric materials such as silica can further enhance their luminescence property. The silica shell protects the doped semiconductor nanoparticle from degradation and conquer molecules, resulting in long-term stability and improved fluorescence property. Summary. The coating of colloidal particles with shell offers a simple and flexible way of modifying their surface properties, including their luminescence property. Various combination of core shell material and shell thickness can be used to synthesize functional materials with novel properties. The enhancement of the luminescent particles of colloidal particles have important applications in various fields, including biotechnology, environmental monitoring, and optoelectronics. Further research and development in this area can lead to discovery of new improved functional materials with enhanced properties. Optical properties. Optical properties show variations in their absorption and band position, which changes in particle size. Coating metal shell on silica allows for tuning the absorption band from visible to infrared wavelengths. The thickness of the core to shell layer affects the position of the surface plasmon resonance SPR band. The metal nanoshell with plasmon resonance in the IR region are suitable for biological applications due to their transparency to biological tissues. The dispole-to-dispole coupling between neighboring particles affects the plasmon band position, with thick coating leading to larger separation of particles and a red shift in the band. Changes in shell thickness can be used to tune the color of the core shell particles and monitored spectroscopically via SPR bands. Luminescence properties. Semiconductor nanoparticles, also known as quantum dots, are fluorescent material that are used in various applications such as biological labeling and imaging. However, they are prone to photobleaching, which reduces their luminescence over time. To overcome this issue, a coating of silica is applied to them. Partial assemblies of semiconductor nanoparticles where the core is coated with another layer of semiconductor have been found to enhance luminescence. The core And the choice of shell material is crucial as it affects the localization of the electron hole pair. As you can see, this is a type 1 and type 2 representation of the luminescence property of nanoshell particles. Type 1 and type 2 nanostructure have different properties based on spatial separation of carriers, the lifetime decay of excision, and quantum yield of core shell particles is much higher than individual semiconductor nanoparticles. Organic dyes are similar to semiconductor nanoparticles but are not photostable and cannot be dispersed uniformly in water. Silica coating on these dyes enhances their luminescence and make them disperse uniformly in water. Overall, the use of silica coating in core shell assemblies of semiconductor nanoparticles in biotechnology, optoelectronics, and photonics. Thank you all for listening.